look at factoring polynomials. Again, review, right? It's just that we're doing all those methods of factoring in 20 minutes. And then you'll go home and you will do your homework and if you, even after this, if you're like, I want to come to extra help at lunch, then you come. Some students come to extra help just to do their homework and ask me questions as they do their homework. That's cool. All right. So we are basically going to look at all the methods of factoring. First one is common factoring. Okay. I usually jump off my desk, but I am not properly dressed to remind you. Folks, what do you do first? How, when? Sometimes? Always. So you always check if there's common factoring. Reason being, if there's a common factor, you make the coefficients, the numbers smaller, and you're able to see, oh, there's different methods of factoring in here. So we always common factor first. Otherwise, you'll be like, oh, this is not factorable. Well, it is. You just forgot to common factor. Okay, I'm going to stand here. And Rojan, I feel like you need to move. It's up to you. It's up to you. But like, if you can see, cool. All right. So when we find common factor, find the greatest common factor. And then you write it in front of the brackets. So let's look at question A. We are looking at the number, the numeric common factor, and the variable. So the number is which number can both of these coefficients be divided by? Show me with your fingers. Muy bien. Good. What's the other number that both of them can be divided by? Yeah, but one is not a common factor. Okay. So the common factor numeric is 2. And then when I look at the variable, it's literally the one that has the lowest exponent. So as long as both terms have the same variable, the common factor is the one with the lowest exponent. What is the variable common factor here? Is it v or v squared? V, because that's the lowest exponent. That's the common factor. Okay, now I'll remind you what we do. You do not have to do this step, but this is what I do. So then I take the expression and I divide each term by the common factor, right? When we are common factoring, we are dividing out the common factor. And it doesn't go away. Okay, 4 divided by 2 is 2. V squared divided by v to the power of 1. Okay, quick reminder, if I have x to the power of 10 divided by x to the power of 6, what is it? X to the power of, good. So what are we doing with the exponents? Subtracting. Good. So v squared over v is just v. 10 divided by 2 is 5. What's v divided by v? They cancel out, but what is v divided by v? What's sly divided by sly? You're going to tell me it's nothing. It's 1. It's 1, right? So v divided by v is 1. So I'm saying 5 times 1. Because it's 1, we don't write it. But it's not nothing. Okay, can I do anything more? No, I stop. This is common factoring. It's literally taking the expression and reducing the coefficients and reducing the exponents. That's all common factoring is. Okay, is there another common factor? No. Next, factoring trinomials. This is such a fun one. All right. When a equals 1, now a is in front of, is the coefficient of x squared. right? So when I have a trinomial that looks like this, x squared plus 7x plus, I don't know, 45, I'm just making something up. This is a simple trinomial because x squared does not have a coefficient. So if we have a simple trinomial, we factor by finding the product and sum. Let me look at that. So here we go in question B. Okay, this is a simple trinomial, although it's a bit more. I draw a plus on top of the middle term, and I draw a times on top of the last term. You might have done it differently. Cool, no problem. And basically, I'm looking for two numbers that add up to be the middle term and multiply to be the last term. And they have to be the same numbers. Okay? So something times something ends up being positive. They're either going to be two negatives or two positives. What are the numbers?
-2 and -2.
Yeah. And if I add two negative numbers, it makes it more negative. And so in this case, I draw my brackets with an X, and I just put in those two numbers in the back of the brackets. And that's factored. So when we're factoring, we're trying to reduce the degree of the polynomial, meaning the exponent. Is the exponent lower in the second line? Yeah, what's the highest exponent that we see here in this line? A 1, right? So going from a squared to a 1, that's better. Any thoughts here? Yeah.
Would you want us to like simplify into x minus 2 squared?
Absolutely. Right? And we will come back to it because this is actually a shortcut. And I'll be looking for that in the diagnostic. Okay, I won't mark it wrong, but if you don't find this shortcut, it means you don't yet see the perfect square trinomial. I'm going to call it a perfect square trinomial, also known as a PST. So this is how we look at, here, let me give you one truly simple. Okay. I want you to solve this simple trinomial or factor this simple trinomial. And we're trying without a calculator, right? And then I'm just looking for those two numbers. Yeah? Okay, if you need to practice factoring trinomials, if this didn't come to you quickly, which probably it didn't, right? It's just like oh yeah, I really need to sit there today for an hour and practice my factoring. Because this factoring, folks, next week, if you can't factor, like we're taking factoring to the next level. Okay, factoring is going to be like your regular adding and subtracting. We're going to work with rational expressions, and factoring is just going to be something we do. So please make sure that by the end of the weekend, you are strong and you've reviewed your factoring. Let's recall what we do when it's not a simple trinomial, when your a value is not 1. So the x squared has a coefficient. For example, 4x squared plus 20x minus 17. I'm just making up numbers, right? This is not a simple trinomial. Can I common factor this one? No, right? So it truly is a non-simple trinomial. So we are going to use decomposition. I know a lot of students use decomposition for simple trinomials. That's a lot of work and a waste of time. Okay, so really try to do simple trinomials in one step, the way that I showed you here. Okay, so let's do decomposition. Let's remind ourselves what it looks like. So I look at question 3. Folks, what's the first thing I ask myself? Yeah,
If you can common factor it.
that's it. Is there a common factor? Is there a common factor? Good, but we checked. Then I see, oh, a is not 1. So this means we need to use the method called decomposition. Okay, how do we do it? Well, I still place a plus on that middle term. Okay, so I'm still looking for 2 numbers that add up to 7. Again, your teacher might have taught you a different method. Use whatever works. And then, whenever I draw an arc, it means I'm multiplying. I'm going to find 2 numbers that multiply to equal the product of these 2. So something times something equals 3 times negative 20. Okay, take that in and ask me questions. So now I'm looking for 2 completely different numbers. Like my 2 factors might not be 3, 7, or 20. Okay, don't tell me the answer yet. I want everyone to struggle with this. So what are 2 numbers that multiply to give you negative 60, add up to give you 7? So I might be like, how do I get 60? Well, it's 20 times 3. Well, it's 15 times 4, 6 times 10, 5 times 12, 2 times 30. And as I look at this list, I'm like, do any of those give me an answer of 7? And I see the negative, so I'm like, okay, I'm subtracting. All right. So these are my factors. Okay, so I know they're 5 and 12, but now I have to figure out which one is negative and which one is positive. Right? One of them has to be negative, and I'm going to look at these at the 7. So when I add them up, the answer is positive. So which one is positive? Is it 5 or 12? 12. Okay? If your sum, right, what you're adding is positive, that means the bigger number is positive. Okay. Now, we're not done. We found the magic numbers. We can't just pop them into the brackets. Now, we decompose the middle term. So I take that 7x, I'm going to keep it blue, and I'm going to decompose it into minus 5x and plus 12x. So they still equal to 7x, right? It's just I've decomposed them. I've written them a bit differently for the sake of factoring. And then I did not change the first and last term. And this is when we do something called factoring by grouping. Factor by grouping. Where we take the first 2 terms and the last 2 terms, and what do we do with them? Yeah. Beautiful. We find the common factor. Okay. So numeric common factor of 3 and 5, nothing. But they both have an x. So the common factor here is x. So 3x squared divided by x is just 3x. Negative 5x divided by x is 5. What's the common factor of the second part? Could be 2.
4.
4, right? We look for the highest number. Ooh, music to my math ears. Why do I love this? Because now I see there is yet another common factor. If I look at this term and this term, right, because terms are separated by pluses, I see that they both have the same common factor of 3x minus 5. So you might not be realizing it, but what we are doing in this step is we are just taking out the common factor and writing down what remains. No way. How do you do this? Do you do it this way or do you do it in your head?
I do in my head. I'm trying to fold.
You just do it in your head?
Yeah.
Yeah, I figured.
Just some possibilities.
Yeah. Anyone else do it in their head? Yeah. Oh, yeah.
The squared on the 3x.
No. It's like I'm saying, oh, each of these has a 3x minus 5. So I'm going to divide each term by 3x minus 5. So I cancel these, and what's left? X plus 4. Okay, I want to show you what I was talking to Noe about, just because I know different countries teach things differently. There is a super shortcut. It's literally doing it in your head. Okay, so we go from here to the answer. I'm like, I know there's going to be 2 brackets. Okay, I know each is going to have an x. And then I look at the 3x squared. What are the only 2 factors of 3x? Oh, sorry, of 3. 3 and 1. So one of the brackets must be a 3. One of the brackets must be a 1. Agreed? No other way. Then I look at the last number, 20. Well, 20 has a lot of different variables. A lot of factors. So now I try things that get me to the 7, right? Because this plus this has to equal to 7. So let's say I'm like, oh, maybe negative 20 will be minus 2 plus 10. Okay, so I just do this in my head. And I'm like, okay, 3 times 10 is 30. Minus 2, that's 28. No, that's not going to work. Okay, what's another factor of 20? Anything else besides 4 and 5? No, it's 4 and 5. Okay, so I'm going to be like, okay, 4 and 5. 3 times 5 is 15. One of them has to be minus. 4 times 1 is 4. 15 and 4. That doesn't get me to 7. But what if I write the 5 here and the 4 here? 3 times 4 is 12. 5 times 1 is 5. 12 and 5. And I want the 7 to be positive. So do that. Did that at all resonate with anyone? Is anyone like, okay, I kind of get it? Yeah. So it takes time. It takes mental math, but it's one line, right? So I would love for some people to challenge themselves and try to do it in one line. I end at 10:20, right? I do. Good. All right. Moving on. Before I go to PST, let's do difference of squares. Okay? Factoring a difference of squares. I love it. Okay. we factor using a difference of squares if both terms, there are two terms, both of them have a perfect square, i.e. you can take the square root of both terms, and more critically, there has to be a negative between them. If there's a plus, you cannot use difference of squares. So this is sort of like undoing the flow rule. So let's see how we would factor 49y squared. I'm going to have two brackets. What is the square root of 49? Square root of y squared? Y. So I write 7y at the front. What is the square root of 144a squared? 12a. Does it matter where I put the plus and minus? Nope, because I'm multiplying these two terms. One gets a plus, one gets a minus. Okay? Then we have factoring a perfect square trinomial. This is the trickiest one to recognize, Michael. Because you look at a trinomial and you're like, oh, I'll just do regular factoring. But there's a great shortcut. And sometimes that shortcut is really important. And so when we have a trinomial where the middle term is a double of the product of the first two terms, we will factor it as a perfect square trinomial. Now, the hint to me is that first and last term are perfect squares. First and last terms if the first and last terms have a square root, then you check, is the middle term the product of the two terms double? Let's practice that in real life. Okay. No, I'm going to make one up. 4x squared. So I'm like, okay, first and last term have a square root. That's 5, that's 2, so 10. So the question is this a PST? Is it a perfect square trinomial? And I'm like, well, 4x squared has a perfect square. 5, you can take the square root of 5. Now let's check. What's the product of 2x and 5? 10x. Double it, it's 20. It works. So will I put a minus or a plus inside the bracket? Yeah, because of this negative. And then I make sure that I write that binomial is squared. Okay, 2 more questions. Question D, help me out, folks. William, what do I want to do? First and always.
Check if there's a common factor.
Is there a common factor, folks?
Yes.
What is it?
3.
Oh, okay. So we're going to divide out the common factor. Oh, and it ends up being a simple trinomial. Oh, this is easier. So I keep that 3 out front, and then I draw a big plus on the middle term and a times on the last term. And I'm looking for 2 numbers that add up to -8 and multiply to +15.
-3 and -5.
Yeah. And folks, if you're like, oh my God, I couldn't get it that fast, you just need to practice more. Okay? Very attainable. You just need to practice more. So see how it's beautiful? Like, could you have done this with decomposition? Yup. Would it be ugly? Uh-huh. But if you common factor, you're like, oh, and if you did it by decomposition, you would still have to common factor at the end. Yes.
Would we still get full marks if we did decomposition on the test?
As long as you find that common factor at the end. Yeah. All right, last one. Is there a common factor? Absolutely. What is it? Both numbers are even. So what does that mean?
It's 2xy.
At least it's 2, right? Okay, it's going to be 2. It might be more, but let's see where we go. Then you look at the x, and you're like, okay, both have an x. The lowest exponent is an x and a y. So what happens when I divide everything by 2xy? Well, I get 25 x squared minus 64. Oh, Miss Sly, you tried to trick us. How will I factor this? Come on, come on, come on, come on. What's it called? What's it called? Difference of squares. Say it out loud. Be proud. You got it. Okay. Folks, you obviously, I would say, everyone's got a lot of homework just because we're really trying to review and remind ourselves of this beautiful factoring.